Hello everyone, I am Imanshu Mishra, and this week we will be solving question from kinetics. Until last week, we have solved question from kinematics where we were concerned about the velocity and acceleration of a particle or a system. So, we solved plenty of problems related to that. But from today onwards, we will be solving question where we try to relate the force with the acceleration or velocity, or the movement with the angular acceleration or angular velocity. So we try to relate these quantities with each other, and in the problem we will see that how force influences the acceleration or velocity or vice versa, and similarly how movement actually influence the angular velocity or angular acceleration. So until now we have not talked about force and movement associated with the velocity and acceleration or angular velocity and acceleration, but now we will try to bring some connection between these two quantities, between the dynamical variable like force or movement and the kinematics variable like velocity and acceleration. So today we are going to solve problems from variety of concepts. So we will be talking about how force and velocity relates to each other, or how force and acceleration relates to each other. Then we will talk about the linear momentum, and then we will briefly discuss how the movement and the angular acceleration relates to each other, and then briefly about the angular momentum, and then we will be solving question related to that. So before solving question, as usual, we will be uh, briefly revisiting the concept that you might have seen in the NPTEL class. So to clear a concept, just visit the NPTEL videos for week 11, and here we will be start with basic recapping or revising those concepts. So I will not go into a detail, so just basic revision of the concept, and then we will be start solving question in this tutorial. So in this tutorial we will be solving question related to the kinetics problem, where we will be associating the dynamical variables like force and movement with the kinematic variables like acceleration and velocity and so on. So let's say there is a body. First, let me define the Cartesian coordinate system. This is x and this is y, and I have some arbitrary body with some point here, and the position vector is, let's say, r. This is point P. So this is x, distance x from the origin, and this is distance y from the origin. And let's say there is a force, external force, which is acting here, Fi, and some internal force, small fi, and there is a resultant force which is acting. Then how to define the translation of a center of mass of a body? So if G is a center of mass, of body, then it will satisfy summation of force equals mag, where this is acceleration of center of mass G. So this equation tells that the sum of all forces acting on a body is actually equal to mass times acceleration. Right? Now let's say if I summing the moment at point P. So this is my point P and I will going to sum the moment from this point. Then I have R cross Fi plus R cross small fi equal to R cross Ma, right? Because at the left hand side you will see there is a force, there is a movement due to a force, and at the right hand side you can see there is a movement due to mass multiplied by acceleration, because earlier we saw that the summation of all force equals to mass time acceleration. So the these force actually create a movement which is I have shown in the left hand side, and this summation of these forces is actually equal to mass time acceleration. So mass time acceleration will also create a movement which is I have shown in the right hand side direction. So this left hand side is just a summation of all movement. So this I can actually write as mp equals r cross ma. So this is the expression where the point P is actually coinciding with the center of mass G. Then I will get this moment expression which is r cross ma. Right? Now let's say this point here, this point is actually moving in a curvy linear direction. Okay, so this is the point which is moving in the curvy linear direction, and in the previous tutorial we saw that if body is moving in the curvy linear direction, then what happens? You will have a two component of acceleration in the tangential direction and in the normal direction, right? So this tangential direction acceleration is toward the direction of angular acceleration. So if this is the direction of at, then my angular acceleration should be in the same direction, whereas this normal acceleration should be directed from point O, whereas the body is rotating with an angular velocity omega in this direction, right? So the movement, summation of movement along point P can be written as r cross m ap, which is a translational acceleration, and alpha cross r minus omega square r. So this will be my expression for the movement. I can rewrite or simplify this expression as m r cross ap plus r cross alpha cross r minus omega square r cross r. So you can see this term is 0 because there is a term r cross r, and the cross product with its own vector should be 0. So this is 0, and you will have the movement at point P, which is m r cross ap plus r cross alpha cross r. So this will be the movement in case the body exhibit the curvilinear rotation or the motion in which there is a tangential and normal component of acceleration which is exerted. So the above formula, this equation actually is suitable for any coordinate system, because you can see we have written down this equation in a vector coordinate. So it is a general equation. Similarly, this equation is also a general equation. So you can use this equation in either Cartesian or in any curvilinear polar coordinates and so on. But this equation is actually valid if there is a curvilinear motion which is going on. Right? Similarly, you can actually define the movement in the Cartesian coordinate. So in the Cartesian coordinate, you will have mass xi cap, yj cap, and x and y is already defined in this figure, cross apx, apy, so plus xi, yj, and if there is an angular acceleration, alpha plus xi, yj. So on solving this, you will get minus y ap x plus x apy plus alpha x square plus alpha y square and minus y apx x apy. So x square y square is r square, so alpha r square. Then the resultant movement will be, you can write in the scalar form, so it will be integration of y. So here m, I am taking the mass of a very small element which I will denote by dm. So it will be y dm apx plus x dm apy plus r square dm alpha. And you can see that this term is the first movement, this is the first movement, whereas this is the second movement. And in the mechanics, the first movement is always referred to center of mass, and the second movement referred to the moment of inertia. So this quantity is actually a moment of inertia, whereas this is the location of center of mass or center of gravity in case both are coinciding. So this will be y bar m apx plus x bar m apy plus, and this quantity is the moment of inertia, because in mechanics the second order quantity is actually referred to a moment of inertia, so it is ip alpha. So this is the summation of movement at point P in the scalar form, right? So basically we are actually using this expression to define the movement in a curvilinear as well as in the Cartesian coordinate. In the curvilinear, you will have a two component of acceleration along tangential and normal directions, but in a Cartesian it will be referred as, or it will be along in the x and y direction. And if, let's say, your point P coincide with the center of gravity G, then what happens that this distance vanishes, because these are the distance of point P from the center of gravity, right? So if point P coincide with center of gravity, which means that point P is on the center of gravity, and this corresponds to x bar and y bar equals to 0, which means my summation of movement will be given by ig alpha. And if it is not coinciding, if P is at different location than G, then what happens? The location of P can be defined by this x bar and y bar. So these x bar and y bar will not be a 0, then you need to use this whole equation. But if point P is at the center of gravity, then x bar equal to 0 and y bar equal to 0, because the point P is itself on point G, and that's why the distance between P and G is 0, and that is given by x bar and y bar equals to 0, and then the moment will be only given by this quantity I, which is moment of inertia times angular acceleration alpha here. Right? So let's talk a bit about the linear momentum. Let's say I have a point O here, and this is G, center of gravity of some body. Let's say this is some point M, and it has the position vector rho I. It's a displacement vector Ri from O, right? Then my linear momentum will be given as Gi equals mv. Right? And if I take the time derivative of this, if I take the time derivative of mv, I will get m dv by dt, which I can write m v dot. So this will be given as dg by dt equals mv dot, and v dot is actually the acceleration, so it is ma. And you can see that this ma is actually the summation of force that we have discussed at the beginning of the class. So this actually represents as the summation of force, and from this equation we can see that the rate of change of momentum is actually given by the summation of force, right? So this statement says that resultant of external forces on system is equal to rate of change of linear momentum. Similarly, we can actually define the angular momentum. So angular momentum of mass system at some point is vector sum of moments of linear momenta about O. So if h is the angular momentum at point O, then it is a summation of all linear momenta. So mv is the momenta, and it is a summation of moments of momentum. So it's a movement of linear momentum, right? So angular momentum is vector sum of moments of linear momentum, right? So this r cross quantity is the movement, and it is the movement of this linear momentum mv. So it is the moments of linear momentum, right? And if I take the time derivative of above quantity h dot o, then I will get r dot plus r multiplied by mv dot, right? So this r dot is v. This r dot is actually the velocity, right? Which means I am taking the cross product between v cross mv, which is 0, because you cannot take the cross product between the same vector. So this quantity is 0. So you will get h dot equals summation of r cross mv dot. and this is the acceleration, right? And you know the force is equal to mass times acceleration, so this will be summation of r cross f, right? And you know that this r cross f, what is this quantity? This is the moment, because we already defined moment several times as r cross f, or in the scalar form moment is just force multiplied by perpendicular distance that we have seen from the beginning of the tutorial from week 1. So this is actually the moment, so h dot equals to summation of moments, right? So this quantity actually tells you the vector sum of movement is equal to rate of change of angular momentum, right? And you can see this quantity is actually similar to the quantity we have derived here. So for the linear or the translational motion, the rate of change of linear momentum equal to summation of force, and for the angular motion, the rate of change of angular momentum is equals to summation of movements. So it's a similar concept here. For the linear motion, the rate of change of momentum is summation of force, and for the rotational motion, rate of change of angular momentum is summation of moments. Here. So now, at the center of gravity, the moment expression is cross m r dot. So this is a position vector from the center of gravity to some point having the mass m. And if let's say there is a point p which is a random point, then how should we find the angular momentum? So this is the angular momentum with the at the center of gravity. If body have a center of gravity, body have some point which is the center of gravity g, then along that point this is the angular momentum. But if let's say I have given a random point p which is at some random direction far from the center of gravity, then what will be the moment along that point p? So the angular momentum at point P will be given by angular momentum at the center of gravity plus rho cross mv. So this will be my expression for the angular momentum at some random point P. And similarly, my movement will be at point P will be movement at point G plus rho cross summation of force. So this will be my movement. So I can deduce the expression of movement from the angular momentum, because we have seen that both are related. My rate of change of angular momentum is actually the summation of moment. So from this equation I can actually write down the expression for summation of moment at point P, which is equal to the summation of moment at the center of gravity plus rho cross F, where rho is the position vector. So having described these fundamental concept, let's start solving problem based on this concept. So we have seen multiple concepts. The first concept we have to look about is the relation between force and angular and the acceleration, linear acceleration. Then we look about the relation between the linear momentum with the translational force. Then we talked about the relation between movement and angular acceleration. And we saw that in the curvilinear and Cartesian coordinate, how to define the expression for this movement. And we also saw that the rate of change of angular momentum is actually defined as the summation of movements. So today in most of the problem we will be solving uh, question based on these two concepts. So let's start with the first problem. Here, each of the three balls has a mass m and is welded to the rigid equiangular frame of negligible mass. The assembly rests on smooth horizontal surface. If a force F is suddenly applied to one bar as shown, determine the acceleration of point O and the angular acceleration theta double dot of the frame. Right, so we need to determine the acceleration and the angular acceleration, and we have given a three balls of mass m and there is a force F which is acting. So you can see there is only one external force which is acting on the system, and there are three balls of mass m. Then to determine the acceleration of point O, we just need to use the relation between force and acceleration. So which is force in the x direction equals to 3 ma, right? Because there are three balls, three particles with mass m, right? And since this is the only external force, my acceleration will be given as, which is equivalent of acceleration at point O equals to F by 3m in the ith direction. So this will be my acceleration. Now to define the angular acceleration, we will be using the movement principle. So just recall that the movement is equals to rate of change of angular momentum, right? So first let's describe the rate of change of angular momentum, or first let's describe the angular momentum, then we will define the rate of change of angular momentum by taking the derivative of angular momentum with respect to time, and that quantity is equal to summation of movements. So my angular momentum will be 3 . So you can see that we discussed the angular momentum can be defined as r cross m r dot, right? So this is my angular momentum, but in a scalar form I can write h equals r mv. Now there are three balls, which means 3m v r, and the velocity from the previous tutorial we use the velocity as r theta dot, right? So I can write my velocity as r theta dot here and r. So my angular momentum is 3m r square theta dot. So this is my angular momentum. Now how to define the angular acceleration? So angular acceleration is theta double dot. So if I take the derivative of this, I will get the rate of change of angular momentum with respect to time, and here I will get theta double dot. And this quantity is actually equal to summation of movement, because the rate of change of angular momentum equal to summation of movement. So dh by dt, so I am taking the time derivative of this expression, equals to d by dt 3m r square theta dot. 3m r square, I will get theta double dot, and here it is equal to h dot, which is equal to summation of movement at point G, right? And you can see that there is only one force is acting, and therefore there will be a movement due to this force, and the perpendicular distance is b. So the movement will be Fb. Summation of movement will be Fb, because only one force is acting and it has a perpendicular distance b from point O, then the summation of movement will be Fb. This quantity is equal to summation of movement, because the summation of movement will be equal to rate of change of angular momentum that we have discussed briefly in the beginning of the class. So summation of movement will be Fb equal to 3m r square theta double dot. So my angular acceleration theta double dot will be Fb equal 3m r square. So this is my angular acceleration. So just to recap the problem, here we have given the three balls of mass m, and there is an external force which is applied on the system, and we need to find the acceleration and angular acceleration of the system. So to find the acceleration, given that we have one external force which is acting, it is pretty much straightforward problem. So we use a relationship between the force and acceleration, which is given by F equals ma. Now since there are three balls, it will be 3 ma, and from that you can easily find the expression for linear acceleration. To find the angular acceleration, we first define the angular momentum, which is r cross mv. So we write down the expression for angular momentum in a scalar form, which is r mv. So v is actually can be defined by angular velocity, which is theta dot. So my angular momentum can be defined in terms of theta dot, right? Because theta dot is my angular velocity. Now once I define my angular momentum, which is a function of angular velocity, theta dot, if I take the time derivative of this quantity, d by dt, then this will become a function of theta double dot, and this is what we need to find. We need to find theta double dot, and we also know that this time derivative of angular momentum is equal to summation of movement. So basically this summation of movement will be a function of theta double dot, right? Because this quantity, rate of change of angular momentum, is a function of theta double dot. Then if rate of change of angular momentum is equal to sum of movement, then sum of movement will also be a function of theta double dot. So what we did, we calculate this theta double dot in terms of summation of movement. And this summation of movement, since there is only one force is acting, the movement will be due to this only one force, and the movement will be Fb, where F is this force and B is the perpendicular distance from point O. So this theta double dot will be given as a function of Fb, and this is what we got in the expression. Theta double dot is defined as Fb divided by 3mr squared. So let's solve the next problem. So here a shell with a mass 20 kg is fired from a point O with a velocity u 300 meter per second in the vertical exact plane. When it reaches the top of its trajectory at P, it explodes into three fragments. Immediately after explosion, fragment A is observed to rise vertically a distance 500 meter above. The fragment B is seen to be horizontal velocity Vb and eventually lands at point Q. When recovered, the masses of a fragment A, B, C are found to be 5, 9, and 6 kg respectively. Calculate the velocity which fragment C has immediately after the explosion. Right, so the problem is there is a shell of mass which is actually projected on the sky, and after reaching point P, it actually divided into three pieces. Now one piece is actually rise vertically, and the second piece has some velocity Vb, and the third piece has some velocity Vc which we need to find. So here we can use the momentum relation, where we use the linear momentum which is conserved, which means that, so this is my earlier initial velocity of a single particle equals to mva, mvb and mvc. So this is the conservation of linear momentum. It says that my initial momentum equal to my final momentum, and the final momentum given by three quantities, because there are three particles which is there at the final stage. So initially I have only one particle, then what happens, it is split into three particles. So the momentum conservation tell me that the momentum of one particle, which is the initial state, equal to the momentum of these three particles at the final stage, which is basically this expression. So this is my initial momentum, and this is my final momentum due to three particles. And these are the linear momentum. We are not talking about the angular momentum here. So in the question, so what we need to find, we need to find the velocity of particle C. So to find the velocity of particle C, we need to determine velocity of particle A and velocity of particle B, right? So for particle A, in the question it is given that fragment A is observed to rise vertically at a distance of 500 meter. Right? So velocity of particle A will be given by root 2 gh, and h is 500 meter, because this is h is the vertical distance, and in the question we have given that it rises 500 meter vertically up in the upward direction. So my VA will be 2 multiplied by 9.81 multiplied by 500, and I will get VA is 99 meter per second. Now for the particle B, it is given that it seemed to have a horizontal velocity VB which eventually land at point Q, right? So this was the point P, and the particle B actually land at point Q, which is 4000 meter from the origin. So this is the distance, 4000 meter, and then I can actually obtain the velocity of point B as distance divided by time. So I need to calculate time it takes to reach point Q, right? And from the projectile motion I can define my time as uz by g, which is 300 4 by 5 9.81. So I'm taking the component here 3 by, so this is my 5 and this is 3, which will give me 24.5 seconds. Then my VB will be distance by time. Distance is 4000 and time is 24.5. So it will give me 163.5 meter per second. Right? So now I can use this formula. I need to calculate the velocity V. So here it is given 300 meter per second, and I need to consider this component. This component, which is V multiplied by 3 by 5. So in the first week lecture we actually talked about how to get the components. So for example, let's say this is a velocity V, this is x-axis, and it is, we have given theta. Then how to find the component of this velocity along x-axis, which is directly given by V cos theta, which is Vx. But instead of angle, if we have given the sides, let's say this is 3, this is 4, then using Pythagoras this will be 5, then how will we calculate the velocity along x? So it will be just the ratio of the side which define the vertical and horizontal component of velocity. So similarly here it is actually 3 by 5 V. So it will be m v equals mva mvb plus mvc. So the initial mass is 20 kg and v is 3 by 5 v, and v 300 multiplied by 3 by 5. Now ma is 5 and it is in z direction, and this is in I direction. And my velocity VB is 163.5. So this is a magnitude. And what is the direction? You can see it is in both x and y direction at an angle 45, right? So I cos 45 in x direction and sine 45 in j direction, plus m mass of particle C, which is 6 Vc. Now I will be solving this. So on solving this, I will have so this will be 2560 I minus 5k minus 1040j equals 6 VC. This will be VC in the vector form 1 by 6 2560 I minus 1040j minus 5k. Sorry, there will be a multiply by 99, so this will be multiplied by 99. So this will be your vector quantity or the velocity of fragment C. So again, it was quite a straightforward problem. So we have given a projectile, and initially it is of mass 20 kg and shoot at a velocity of 300 meter per second. And at point P, it is given that it is divided into three parts, A, B, and C, with different masses. And we are given that fragment A is actually rising vertically. So and fragment B is land up at some position which is given at point Q, and we need to find the velocity of fragment C. So we use the concept of momentum conservation where we say that my initial momentum due to particle of mass 20 kg is equal to my final momentum due to 3 particle at split, which is given by this relation here. That is my mv at initially equal to my mass multiplied by velocity at final momentum due to these 3 particles. So basically there will be a 3 momentum due to this 3 particle. So to calculate the velocity of fragment C, we need to calculate the velocity of fragment B and velocity of fragment A. So for fragment A, it is given that this fragment A is actually rising vertically after its split. So we use the formula root 2gh to find the velocity of fragment A, which is 99 meter per second. And to calculate the velocity of fragment B, first we calculate the time and then use distance by time equation to calculate the velocity of fragment B. Then we use the momentum conservation equation to calculate the velocity of fragment C. Now let's move to the next problem. So here, if the 4500 pound van has front wheel drive and the coefficient of static friction between the front wheel A and the road is 0.8, determine the normal reaction on the pairs of front and rear wheels when the van has maximum acceleration. Also find the maximum acceleration. Neglect the mass of the wheel. So basically we have given a car which has the center of gravity G, and it has a wheel here, and it is moving horizontally, and we need to find the acceleration and the normal reaction on this wheel. So there will be a weight from this center of mass, and there will be a normal reaction. So this is, let's say, point B and this is point A at both the wheels, that we need to find out. And there will be a friction force Fs, which is mu Na. So we are given the coefficient of friction between wheel A and the road, which means the friction is due to this normal force at A only, because there is no static coefficient, no static friction is given for the rear wheel. Right. So to determine the acceleration and the normal reaction, we will be using the set of equations. So we have defined that the summation of force is equal to mass time acceleration. So here we can write the same equation, we can use the same equation, that the summation of force is equal to mass time acceleration. Now since we are dealing with the two-dimensional object, we can write this expression by assuming we are working in the Cartesian coordinate. So this is my Cartesian coordinate x and y, and then I will write this equation in the scalar form. So I will write first in the x direction and then in the z direction. So my summation of force in the x direction will be equal to m times acceleration in the x direction. So there will be acceleration in the x direction because this vehicle is moving in the horizontal direction, and the acceleration in the y direction will be 0 because body is not moving in the vertical direction. So this will be my expression here. Now the summation of horizontal force is due to the friction force as well as the force Fa here. So my summation of force will be equals to F minus mu and A. So my F equals to mu and A. So my force is equal to m and acceleration in the x direction, which is mu Na equals m a x. So this is my maximum acceleration as well, because there is no component of acceleration in the y direction, which means all the acceleration is in the x direction. So this is my equation 1, because you can see that here Na and Ax both are the unknown quantities, which means we need one more equation to calculate the unknowns, because we have two unknown and as of now we have only one equation. So for the other equation we will do the summation of force equal to mass time acceleration in the y direction. Now this quantity is 0 because there is no acceleration in the y direction. So basically this is the problem of equilibrium in the y direction, then which is the summation of force in the vertical direction equals to 0. And then what are the vertical forces? So we have Na, Nb and the weight. So it will be NB plus NA minus 4500 equals 0. Right, so this is my equation 2. So here again both are unknowns. So in the previous question we have unknown Na and Ax, but now we have new unknown Nb as well as Na. So when we solve equation 1 and 2, we can solve for Na, but that actually will be given in terms of Ax and Nb. So we need one more equation. So the total number of unknown will be 3, and we have total 3 equations. So we can solve for the 3 unknowns, because the 3 unknowns we have Na, Nb and Ax. So we need one more equation. So that will be the moment, summation of moment due to at point G, summation of moment at point G. So basically it will be equal to, summation of moment will be equal to I times angular acceleration. But since this vehicle is moving in the horizontal direction, it is not moving in the vertical direction, there is no rotational motion which is exhibited by this vehicle. There is only a translation motion which is exhibited by this vehicle. Therefore there is no angular acceleration. So my summation of moment at point G equal to 0, and the moment is due to this force F and these two normal reaction force, and there will be no contribution of movement due to this weight, because we are actually calculating the moment at this point itself. So it will be Na 3.5 plus 0.8 Na 2.5. So this is due to the force, and Nb multiplied by 6, right? So this is 6 feet, this is 3.5 feet. So this is the perpendicular distance for Nb, and this is the perpendicular distance for Na. 3.5 Na, 6 Nb. And this is the perpendicular distance 2.5 for force Fa. So this is the moment equation we will get, which is equal to 0, and this is equation 3. So we have now 3 equations and 3 unknowns. So from first equation I will get Na equals Max divided by mu. So my M is 4500 pound, Ax divided by mu, which is 0.8. So it is 5625 Ax. Now I can substitute this expression of Na into equation 3. So I can write equation 3 in terms of Ax and Nb. Or if I substitute, yes, so it will be 5625 Ax multiplied by 3.5 plus 0.8. Na is 5625 Ax multiplied 2.5 minus or equal to 6 Nb. So this is my relationship between NB and AX. So I will get a, so I got the relation between NA and AX and NB and AX. So if I substitute both expression in equation 2, I can write NB in terms of AX and I can write NA in terms of AX. So this whole equation will be given in terms of AX only, and I can solve for AX. So my NB is 5156.25 AX plus NA is 5625 equal to 4500. So my AX will be 0.4 feet per second square. So once I got AX, you can see that we have defined the relation between NA and AX, NB and AX. So once I got AX, I will get NA and NB. So my NA will be 5625 multiplied by AX, which is 2347, and NB is 5165.25 multiplied by AX, which is 0.48, 0.417, sorry. So this is my NB and this is my NA. So just to recap here, we have solved very similar problem in the previous weeks when we were solving the equilibrium equations and non-equilibrium equations. So here only the difference is the summation of force is equal to mass time acceleration, and the problem is pretty much simple. As you can see that first we made the free body diagram and we identify the unknown, and we identify the overall number of forces which are acting. And from the force balance equation, we found that we have more unknowns than the equations. So we write down the two equations from force balance and we found there are three unknowns, Na, Nb and Ax. And so we need moment equation. And here since there is no angular acceleration, which means the summation of moment is equal to 0. Otherwise it is moment of inertia multiplied by angular acceleration, but if my angular acceleration alpha is 0, which means the summation of moment will be 0. So I took the summation of moment at along point G to write down my third equation. So now it is all algebra. So we have three equations and three unknowns. Then we actually got the three unknowns by solving these three equations. So let's move to the next problem. So in this problem, we have given a 100 kg beam BD, which is shown is supported by two rods having negligible mass. Determine the force developed in each rod if at instant 30 theta equal 30 degree omega is 6 rad per second. So basically we need to determine the force on these rods, and we have given that there is a beam BD which has the mass of 100 kg, right? So this is beam BD, and there is a force TB here at an angle 30, and here TD at an angle 30. There is a center of mass, and the weight is 100 kg multiplied by 9.81, right? And if I consider the rod here, so we need to determine the force at rod at an instant when theta equals 30 and omega is 6 rad per second, which means this rod is having some angular velocity which is given by this. Direction is already given in the figure, which means if this is my curve, it is rotating here. There is a tangential acceleration, and the normal acceleration is toward a joint AN. This is A and this is B, and there is an angular velocity omega, and omega is 6 rad per second. And then there is an angular acceleration, and the direction of angular acceleration coincides with the tangential acceleration, right? So defining the coordinate system, so this is my tangential direction and this is my normal direction. So there is a AT in the tangential direction, and my normal acceleration is acting along my normal direction. So we will do the similar thing. We will do the force balance analysis and the moment balance analysis to determine the unknown quantities. So first, let's do the force balance analysis in the normal direction. So the summation of force in the normal direction equal to mass time acceleration in the normal direction, right? And acceleration in the normal direction, we know that it's omega square r, which is omega is 6 and my r is 0.5. So this distance is 0.5 meter, which is my r. So it is 18 rad per second square, sorry, meter per second square. So then since we have figured out the normal acceleration, we need to find the number of forces. So in the normal direction we have force TB, we have TD, you can see these are in the normal direction, and then component of this weight in the normal direction. So this is my normal direction and this is my tangential direction. So we need to find this component, which is weight cos 30, and weight is 100 multiplied by 9.81. So it is TB plus TD minus 100 multiplied by 9.81 multiplied cos 30 equals to MA. M is 100 kg and angular acceleration is 18. right? So these are the two unknown quantities, TB and TD, which is equation 1. So now let me define the summation of force in the tangential direction. So this is the tangential direction, F equals ma t, that is equals to mass time acceleration in the tangential direction. And in the tangential direction I have a force due to weight. And my mass is 100 kg, and this is the acceleration in tangential direction. So this is my equation 2. As you can see here, the unknown is acceleration. So one, you can actually find the acceleration from this equation 2, but still we have two unknowns in equation 1. So we need the moment equation. So if I take the moment along point G here, I have equal to 0. Then it is minus TB upon 4 plus TD upon 4 equals 0, which means TB equals TD. So this is equation 3. So if I put TB equals TD in equation 1, I will have only one unknown. So from equation 1 I have 2 TB, 100 multiplied by 9.81 multiplied by cos 30 equals 1800. Right? So this summation of moment is 0 because there is no angular acceleration of point G here. Even though there is an angular acceleration here of a rod AB and there is an angular velocity of rod AB, but this point G is actually moving in the translating direction. There is a translation direction and not a rotation direction because it is constant at point B and D. So it is either moving right side or in the left side. So G is like oscillating in this line. Like there is a to and fro kind of motion of point G and no angular motion, and therefore the summation of moment is equal to 0. But there is a finite acceleration at this rod, but we actually take the movement at along point G, and in this bar don't have any angular motion. So now I can find TB here, which is 1800 plus 100 multiplied by 9.8 multiplied by cos 30. Two TB equals 2649.57. So TB will be 1324.7 Newton, and this is equal to TD also, because from equation 3 TB equals TD, and from equation 2 you can calculate the acceleration as well. So AG will be 981 sine theta divided by 100, so it is 9.81 sine theta, sorry, sine 30, 9.81 divided by 2. So this is my AG, which is roughly 4.9 meter per second. So just note that we solve this problem in the normal and tangential coordinate instead of Cartesian coordinate. You can actually solve this problem in the Cartesian coordinate as well, where you define the horizontal as x-axis and vertical as the y-axis, but mathematically it will become more involved. However, the concept will be the same. So instead what we did, we actually defined the tangential and normal direction here. The normal direction is along this force TB. So we don't need to take the component when we define the force along the normal direction, because it will be directly, we can write TB plus TD. So the mathematics will be easy. So when we do the force balance, you can see the equation will simplify when you define in this coordinate system. And similarly for this rod, you define the free body diagram in this coordinate system, and for this rods CD and AB you define again the normal and tangential component of acceleration because it is rotating. So based on that you actually do the force and moment balance analysis. The summation of force is equal to mass time acceleration in both the component, but the summation of moment is zero because this beam is not rotating, only the rod is rotating. So beam don't have any angular motion, it is only having the translational motion, which means the angular acceleration alpha of beam is zero. So the summation of moment, because we take the summation of moment along point center of gravity of B, it is alpha is zero there, and therefore the summation of moment equal to zero. Then we solve these three equations, one due to the summation of moment which is zero, and the other two equation is due to the summation of force which is mass time acceleration. And on solving these three equations we actually found three unknowns, which was TB, TD and acceleration AG, which is the tangential acceleration actually. So it's pretty much the same problem as we like a previous one, and these kinds of problem we have solved in the previous classes as well. So let's move to the next problem. So here the lift truck has a mass of 70 kg and a mass center at G. If it lifts the 120 kg spool with an acceleration of 3 meter per second, determine the reaction on each of the four wheels. The loading is symmetric. Neglect the mass of a movable arm CD. So we need to find the normal reaction of point N, A and of point B. So first let's make a free body diagram. So here the center of gravity is defined at the corner, which means we need to direct the weight from it. So we will not direct the weight of this spool from point C, but the weight is from the center of gravity G. So this is the center of gravity of a lift truck. So the weight of this overall lift truck is from point G, whereas the weight from this spool is from here, point C. So this is 70 multiplied by 9.81 and this is 120 multiplied by 9.81. Now there will be a normal reaction NA, and here it is NB. So I'm not making other parts of this system here. Instead, I'm just drawing the schematic diagram for the force. It's just showing the force. And the distance between NA and center of gravity is 0.75 meter, which is shown in the figure. And from point NB it's 0.5 meter. And this is 2NA and 2NB because it is given in the question there are 4 wheels. So there will be 2 wheels at A and 2 wheels at B. So there will be twice of normal reaction which is acting here. So you can see now in the free body diagram you identify all the forces NA, NB and these 2 weights. So it's all we are left to do is do the moment balance and force balance analysis that we are doing since few problems. So if I take the moment at point say B at this point, this is my B, this is A. So if I take the moment at point B, I will have the summation of force from this weight, from these 2 weights, as well as from the normal reaction. Right, and it is equal to I alpha so I can do the force balance analysis in the vertical direction and then it will be equal to MAY. So the force in the vertical direction is this weight, these 2 weights and these 2 normal reactions. So it will be 2NA plus 2NB minus 120 multiplied by 9.81 minus 70 multiplied by 9.81 equals m, which is 120, and acceleration, which is 3. So this is my equation 1 because there are 2 unknowns here. So when we do the moment balance, I will have summation of force due to 70 kg weight and 0.5 is on perpendicular distance, and due to 120 kg weight with perpendicular distance 0.75 minus 2NA, because I am taking the moment at point B because then this force NB will not create any moment. Similarly, if you take the moment at point A, then this force NA will not create any moment. So you will have only unknown either due to B or due to NA. So here we actually take the moment at point B, this B. So there will be no moment from NB. So only unknown you will have is NA. 2NA multiplied by 1.25, which is 0.75 plus 0.5 equal to mass is equal to 120 3 into 1.7. So here you will get NA as 567.6 Newton, and when you substitute NA here you will have only unknown which is NB. So you will get NB, which is 544 Newton. So again it's straightforward because it's even simpler than the previous one, because here we did not do the force balance analysis in the x direction. We did the force balance in the y direction and take the summation of moment expression to solve the 2 unknowns. So it's a similar problem. Now let's solve a problem where we have to use the relation between movement and angular acceleration, or force and acceleration, and also we need to use the kinematics relation. So we will be using both concept, kinematics and kinetics concept, to actually find the unknown quantities. So until now we actually solve problems where we need to do the force balance analysis and the moment balance analysis. And solving these two equations, we actually solve for unknown quantities. In the previous problem at the beginning of the class, we also use either this or this equation separately. So we first begin with the problems where we only need to use either the force equation or the moment equation. Most of the time we will be using use the force equation only, and using this equation we found the acceleration. Then we come to a problem where we use both of this equation to find the unknown forces and all. Now we will be using these equation plus some kinematics equations, that is the relationship between the velocity, distance and time. So we will be using both these two concepts here. So the question is, the cylinder rod shown in figure has a mass m and length L and is released from rest when theta equals 0. Determine the horizontal and vertical component of force which the pin at A exert on the rod at an instant 90 degree. So you can see that initially the rod is at theta equals 0, and we need to find the force at the rod at point A when the theta is 90. So this is my final state, and the initial state is 0. So from this condition only you can see that you can actually use the kinematics relation, because in the kinematics relation you can see that you know that the final velocity given in terms of initial velocity and acceleration terms. Similarly, the distance can be given by some initial distance and some terms like at square by 2 plus ut and so on. So you need to define this final state of position or final state of velocity from the initial state of velocity or initial state of position itself, and that you have already given in the question. You have given the initial and final position. Right, so again, now drawing the free body diagram here. So this is my normal direction and this is my tangential direction. So I'm again writing equations in normal and tangential direction. This is point G, and in the tangential direction it is making angle theta. This is L by 2 from G, and this is L by 2. And you know that in the normal and tangential direction you will have tangential component as well as the normal component of acceleration. So if you do the force balance analysis in the normal direction, it will be equal to ma in the normal direction. We have acceleration in the normal direction, so it will be m omega r rg. So what are the forces which are acting on the normal direction? So only forces an, which is acting in the normal direction, and component of weight in the normal direction. So this will become summation of force, which is an minus mg sine theta. Then at the right hand side, the acceleration part, which is m omega square r is 1 by 2. This is equation 1. Now if I do the force balance in the tangential direction, My tangential acceleration is alpha r, so it is alpha r, and the forces which are acting in the tangential direction are at and component of weight. And my r is 1 by 2. So this is my equation 2. At is unknown here, and here an is unknown. And also we don't know anything about omega and angular acceleration also. So if I write down the moment balance equation and take the moment along point A, along this point A, I am taking the moment. The moment is then due to this weight alone. There will be no moment due to this force An and At, because I am taking a moment from point A. And moment at point A is equal to I alpha, because this rod is rotating. Therefore, the summation of moment will not be a zero. It is I multiplied by alpha. So the moment due to the weight mg cos theta L by 2 equals I, which is 1 by 3 ml square. So this is my moment of inertia multiplied by alpha. And this is equation 3. So you can see what is the unknown in equation 3. Alpha, and equation 2 it is alpha and At, and in equation 1 it is An and omega. So how many unknowns are there? An, omega, alpha, At. So already it's 4 unknown, and it's already 4 unknown, and we have only 3 equations. Now we cannot use any other dynamical equation. We are already using both force component equation as well as the moment equation. So until now we got only 3 unknowns. So using this 3 set of equation will be sufficient to actually found the 3 unknowns. So that this is what we have done in the previous problem, and this is what we have done in the previous weeks when we solve the equilibrium force problems. But here we can use additional equation due to the kinematics. So as we before this question I told that apart from this force and moment balance equation, I will also going to use this kinematics relation. So apart from these equations, let's use some kinematics relations. So one of the kinematics relation is omega d omega equals alpha d theta. So you can see this lecture. So from this relation, we actually derive the equation, which is omega square equals omega naught square plus 2 alpha theta. So this was the angular acceleration we talked about, and in the linear motion it is equivalent to v square equal to u square plus 2as. So this actually derived from this kind of relation. Now we need to solve for omega at theta equals 90. So at theta equals 90, what is the omega? What is the angular acceleration? So here the angular acceleration is, so omega d omega is alpha d theta, then alpha will be omega d omega by d theta. Or I can write it as, so I can actually use this equation, which is equation, this is let's say my equation 4, and I can use here alpha. I can use equation 3 to find the alpha in terms of mg cos theta and put here. So from 3 mg cos theta L by 2 equals 1 by 3 ml square alpha. So m cancel, L cancel, so g cos theta by 2 equals L alpha. So my alpha will be 3 by 2 g cos alpha divided by L. So this is my alpha, right? And I can use this alpha in equation 4. So omega d omega equals 3 by 2 g cos, this g cos theta by L d theta. right? Now you can see you can integrate this equation. So from 0 to omega, omega d omega equals 3 by 2 g by L from 0 to 90, which is given. 90 is the final position. So what you will get when you integrate this equation, writing here, so it is omega square equals 1.5 g by L, and cos will become sine theta at limit 0 to 90. So your omega square will be 3g by L. So this is our omega square. Now you can put this omega expression of omega in equation 1 and solve when theta equals 90. Now that is, at this theta we need to find the unknown quantities which is given. So the sine 90 is 1 and omega square is 3g by L. So equation, what will be equation 1 will become En minus mg equals m. Omega square is 3g by L, 3g by L divided by 1 by 2. So En minus mg equals 3 by 2 mg L. Sorry, this is L by 2. So L will cancel, right? So my En will be 3 by 2 mg plus mg. So it will be 2.5 mg. So this is my En. And similarly I can use here. So here the theta will be 90 in equation 2. So when theta is 90, this will vanish. This term will vanish because cos 90 is 0. So my AT will be m alpha L by 2. And alpha we know. We already found alpha. Here. What is alpha? At theta equals 90, what is alpha? This will be cos 90. So my alpha will be 0 at theta equals 90. Right? So you can see that alpha is a function of theta. So it will be varying with theta. It is not 0 at other theta, but at theta equals 90 it is 0 because cos 90 is 0. So this is 0 at theta equals 90. So in equation 2, this term is 0 because alpha is 0. And this term is 0 because cos theta is 90 and cos 90 is 0. So my AT will be 0. So AT is 0. AN is 2.5 mg and omega is 3g by L. Right, so just to recap here, we have given a system which is rotating. We have given a rod, slender rod which is rotating, and we need to find the force and the reaction forces at A at an instant when theta equals 90. So we write down the force balance and moment balance equation, and we found that there are too many unknowns. So we have 3 equations, but we have 4 unknowns here. So what we did, we used the kinematics equation where we define the relation between the distance and velocity. Here we define, since it is a rotational motion, we define the relationship between theta and omega, and there is a alpha also. So from these 4 equations, we actually found the 4 unknowns. So first we found the angular acceleration expression given in terms of theta, then we found the omega expression, then we substitute omega and alpha expression in equation 1 and 2 to actually calculate the unknown forces En and AT. So in case you have more unknowns than the three equations, which is obtained from some force balance and moment balance equation, you can use the kinematics equation to as a fourth equation to calculate the unknowns. And just remember that, just note that there are multiple kinematics equations. So it's you have to judge which equation you need to use. So here I use omega d omega equals alpha d theta, but there are other two kinematics equation as well. And you need to judge which equation you need to use. So let's move to the another problem. So if shaft BC is subject to a torque m, which is given in terms of time, determine the angular velocity of 3 kg rod AB when time equals 4 seconds starting from rest. Neglect the mass of shaft BC. So this shaft is rotating and we need to find the angular velocity of shaft AB at time equals 4 seconds. So we can use the concept like d like omega equals alpha by t. So my d omega will be alpha dt, and if I am integrating from 0 to omega here and here from 0 to time, so I need to find first alpha here. And how to find alpha? Given that we have given a torque or a moment, so we have given a moment, then how to find alpha? So we know that the summation of moment will be equal to I alpha. So here we have given torque, so this torque will be equal to I alpha. So alpha will be torque divided by I. What is the torque? The torque is given by this expression, which is 0.545 t to the power 1 by 2 divided by I. And what will be the moment of inertia? So we need to find the moment of inertia along point Z, this. So this will be the moment of inertia of rod AB along centroid plus the moment of anode. There will be some distance. So we need to use the moment of inertia parallel axis theorem, because at IZ this will be given by moment of inertia at center of gravity at this point G plus md square. So my IZ will be 1 by 12. So at center of at this point G it will be 1 by 12, 3 multiplied by 0.3 square plus md square, which is 3 multiplied by this distance, which is 150 millimeter, 0.415 square. So my IZ will be kg meter square. So my alpha will be torque divided by moment of inertia, which is torque is 0.45 t to the power 1 by 2, which is given in the question, divided by 0.09. So it will be 5 t to the power 1 by 2. So this is my angular acceleration. So once I got the angular acceleration, I can use this kinematics relation again to find the angular velocity. So if I am integrating this expression, so this is a kinematic equation. You can remember this equation from the previous tutorial. So it will be omega equals, and my alpha is 5t to the power 1 by 2 dt. So on integrating this quantity, you will get 3.33 t to the power 3 by 2. And at time equals 4 seconds, so we need to find the angular velocity at time equals 4 seconds. So it will be omega 3.334 to the power 3 by 2. And solving this, you will get 26.7 watt per second. So again, you can see in this question we have used two concepts. First, since the rod is rotating, we need to find the angular velocity, and we have given the torque or the movement. We have given the movement here. So what is the relationship between, so how to find the angular velocity? So first, we need some relation which give you the relationship or the connection between the movement which is given in the question and some kinematics quantity like angular acceleration, angular velocity, and so on. So we know this expression, which is the summation of movement will be equal to moment of inertia time angular acceleration. So we know that we need to find this. So once we define the angular acceleration by moment by inertia or by torque by inertia, we can use the kinematics relation, because my change of rate of change of angular velocity, which is the my angular velocity will be equal to angular acceleration divided by time. So I can use this equation to integrate here, and then I can define my angular velocity for a given integration limit here. So it's always a connection between dynamical quantities like force or movement with acceleration, angular velocity or velocity. So once you got this, so if you have given the movement or the force, you need to calculate these quantities. And if you have given these quantities, you need to find these quantities. So in this tutorial, we have looked both kind of problems here to find the unknown. So that's it for today's tutorial. We will meet next week.